So good morning, everyone. Good afternoon if it's afternoon. It's in the morning for me, really early. I'm making these plans for Miss Ross. She's going to be out today and tomorrow, but we did want to keep you guys going with the math and things, and so I'm going to run through how to do a few of these. If you don't have a packet yet, please ask the teacher to get you one. You're going to be taking notes on numbers 1 through 4 with me. And with that, go ahead and get your packet ready. Make sure you have your stuff, and we're going to get going. So, you guys have been working on solving equations, and this today is a great day because we get to add fractions to the mix. And I can hear everyone in the room sort of going, "Oh, that sucks. I hate fractions." Well, guess what? So do I. And so we have developed a way to sort of deal with fractions in a more friendly way than you have in the past. Now, I do need to let you know that what we're going to discuss today only works with equations. And I do want to discuss the reason that it works. So before we get into actually solving number 1 here, I do want to talk through an important idea. Let's actually take a look at a simpler equation. Let's say that I had an equation that was like, let me get a thinner pen here, 8 plus 2 equals 9 plus 1. And that is true because both sides of that equation are equal to 10. Now, if I was to do something like add 6 to the left side, which I have no reason to do that, but I could, in order to keep it equal, I would have to add 6 to the other side as well. Now both sides would be worth 16. It would still be equal because I did the exact same thing to both sides. I could also multiply both sides by 3 if I chose to. As long as I do the exact same thing to both sides of an equation, it's going to stay true. So that's going to be a very important foundational idea as we work through these equations today, because we have to understand the idea that when we have an equation, both sides are equal, and if I do the same thing to both sides, they are still equal. So again, just repeating myself one more time and with one more example, I could subtract 386 from both sides. Again, I have no real reason to do that, but if I did it to both sides, it would still be equal. Both sides would still be equal because I did the same thing to both sides. With that being said, the reason that I bring that up is when we have an equation like this, the last thing any of us want to do is deal with those fractions. And so we're going to be creative. And what we are going to do is when we have an equation that has fractions in it, we are going to find a common denominator. And so like if we think about all of these as fractions, that's the same as 6 over 1, that's the same as 3 over 1. And then we have two other denominators that are 4. So what I'm going to do, and this is kind of a little trick, but I'm going to explain why this works. I'm going to choose to multiply both sides of this equation by 4. And we're going to see what happens. And you might be thinking to yourself, Schlegel, why would you do that? That doesn't even make sense. That's okay. Just follow along. So if I was to do that and I was to multiply both sides by 4, I would get 24x over 1. And then remember, when we multiply a whole number by a fraction, we just multiply the numerator. So 4 times negative 3/4 would be 12 over 4, because this 4 times that 3 makes 12 over 4. Then with the other side, doing the distributive property again, I would get 4 times negative 3 is negative 12 over 4, plus 4 times 3 is 12x over 1. Now you're probably thinking, that was the worst thing you could have ever done, Schlegel, because now we have a lot of fractions all over the place and it's worse. But let's take a look at what's going to happen. So I have 24x over 1, which is the same as 24x. I have 12 over 4, which is the same as 3. I have negative 12 over 4, which is the same as 3. And I have 12 over 1, which is the same as 12. The fractions magically disappeared. Now, the reason why this works is because I chose to multiply both sides of the equation by a common denominator. And in this case, that common denominator is 4. So now I have an equation that we should be pretty good at solving by this point. So I'm going to go pretty quickly from this forward here. And so what we would do is I would choose to add 3 to both sides here. Now that the fractions are gone, this is exactly like work that we've done before. So I get 24x equals 0 plus 12x. And then I'm going to have a situation where I need to, this is kind of a strange problem because I'm going to end up getting 0, which is kind of weird. So we will have, just one moment. Next, we will have to subtract 12x, so we get both, all the x's on the same side. And so I get 12x equals 0. Again, kind of a strange equation to start us off here. We divide by 12, and we get x equals 0. So I'm going to ask the person who's running the show here to go ahead and pause this so that you can take notes. And again, remember everyone, the only new learning that we're having today is this idea that I can multiply both sides of the equation by whatever I want. That's going to make some fractions. I'm going to freak out for a second, and then I'm going to realize, hey, this is not bad, because look what happens. Those fractions all divide evenly to be whole numbers. And again, the reason why this works is because we multiply both sides of the equation by a common denominator. So go ahead and pause the video. I'll move on to number 2. So for number 2, we do have a fraction again, in this case, -1/2. I don't like fractions, and so we're going to do something about it. We are going to select a common denominator to multiply both sides by. And so again, to start with, it's sort of easier for me to think of this as like all of these whole numbers are over 1. And this does not have to be the least common denominator. We'll talk about that probably in the next example, but I just need a common denominator. I need a number that all those denominators go into. And I can see that all those denominators go into 2. So I'm going to multiply both sides of this equation by 2. And so what we get on the left is we are going to have -2 over 2 x plus 2 times 1 is 2. And we have another term over there. And then -2 times 5 is 10x. And then on the right, 2 times 1 is 2. I should be putting those over 1. So our next step, we divide these, or simplify these fractions. And so a -2 divided by 2 is -1x. 2 over 1 is the same as 2. -10x over 1 is the same as -10x. And 2 over 1 is the same as 2. Continuing, looking at the left side here, and I should have, Miss Ross would be mad at me if I didn't make my line right there. So looking at the left side again, I need to combine like terms. I have a -1x and a -10x makes a -11x plus 2 is equal to 2. It's kind of weird. We're going to end up with 0 again on this one. So we would subtract 2 from both sides. We get -11x is equal to 0. We divide by -11. We get x equals 0. So again, we ended up with 0 on that one. It's not always going to end up being 0, so don't fool yourself into thinking that. but I will talk through one more time. The way that we get rid of fractions in equations is we find a common denominator to everything. We multiply both sides by that common denominator, and then we end up having only whole numbers, which is great. Go ahead and pause this video so that people can take notes and ask questions and that sort of thing, and I'll move on to number 3. So for number 3, I do have a case where I've got a denominator of 4, a denominator of 1, and a denominator of 2. So I need a common denominator that 4, 1, and 2 go into. And you're probably thinking, hey, they all go into 4, Schlegel. It's not always going to be that easy that you see that they all go into something right away. And so my recommendation is that if you have some and you're not sure, you just take all the denominators and you multiply them by each other, because you will always get a number that they all go into if you do that. So I've got denominator 4, 1, and 2. I'll multiply 4 times 1 times 2 makes 8. And so for this one, I could multiply both sides by 4, but if I didn't see that 2 and 4 both go into 4, I would choose to find a common denominator by multiplying all of my denominators together, and I would see that I can multiply both sides by 8. Now I would get the same answer in the end if I multiply both sides by 4, or if I multiply both sides by 8. It doesn't matter as long as I multiply both sides by a common denominator. So I'm going to have 8 times 3 is 24 over 4, x. 8 times 1 is 8 over 1, and 8 times 1 is 8, and that's still over 2. So again, remembering I only multiply by the numerators when I'm multiplying a whole number by a fraction. Now for the great part, 24 divided by 4 is 6. 8 over 1 is 8, and 8 over 4 is 2. 8 over 2 is 4. So now I have all whole numbers, way better than what I started with. And again, the way that I do this is I multiply both sides by a common denominator. So solving this darn thing, I get plus 8 plus 8. And I've got 6x equals 12. So divide by 6. And I get x equals 2. And again, Miss Ross, I keep forgetting. Sorry, Miss Ross. There's my line going down. So I'll pause the video, or I'll talk through this one more time. So I found a common denominator. It doesn't have to be the least common denominator. I could have used 4. I could have used 8. I could have used 12 or 16 or 20. I could have used any number that 4, 1, and 2 all go into, and I would have ended up with the same answer. And since this was sort of a quick one, just to show that, I will redo this problem. Actually, no, I'm not going to. Take my word for it, everyone. Or if you feel the need to, try it yourself with using 4 instead of 8. You will see that you still end up with 2 as the answer. Moving on to number 4. We got one here that's kind of nasty. We have a denominator of 7, 3, and 21. So I will tell you right now, 7 and 3 both go into 21. But if I didn't see that, and I couldn't figure out that 21 was a common denominator, I could multiply 7 by 3 by 21. I don't even know what that's going to be. I see that 7 times 3 times 21 is 441. Yes, I could multiply both sides of this thing by 441, and I would come up with the same answer as someone who multiplies both sides of this by 21. It doesn't matter what common denominator you use, as long as you choose a common denominator. So I will go ahead and choose 21 to multiply both sides by, because it's going to be less messy than choosing 441. So 21 times 4 and 21 times 2. These are all fractions already, so I don't need to put anything over 1. So 21 times 4 is 84. over 7. 21 times 2 is 42 over 3. And 21 times 124, I don't even know what that is. I'm going to grab my calculator. (21 times 124 is 2,604. That's a lot. Over 21. Okay. And so simplifying those, a calculator is handy. So I just know off the top of my head that 84 divided by 7 is 12. 42 divided by 3 is 14. Don't forget your line, Schlegel. How about that? Okay. And 2,604 divided by 21 is going to be 124. So now I have an equation that I'm very familiar with. It's all whole numbers. Life is good. I hope you're seeing or figuring out by this point that if we have an equation that has fractions, all we need to do to make it way easier is multiply both sides by a common denominator. And then just solving this like we normally do, I'm going to subtract 12 from both sides. I'll get 14x equals 112. And I don't know what that is when I divide the darn thing. I do know that my next step is going to be to divide by 14. And so I get, one moment, 112 divided by 14 is 8. Okay, and I can tell you again, had I chose to multiply by 441 instead of 21, I would have got way bigger numerators, but I still would have ended up with the same exact answer in the end. I still would have gotten 8. I said in the subnotes that I was only going to do 1 through 4. I do have a little bit more time on my hands. So if, I'll leave this up to the sub, if people are feeling like you're ready to go, you can go ahead and go and work on these. But if you would like to see another couple examples, I will do 5 and 6 also, because I have the time to do it. So again, just make a choice of what's right for everyone in the room. So I see 6 and 2 and 1 as denominators here. I need a common denominator that they all go into, or a number that they all go into. And so I see all those numbers go into 6. 6 goes into itself, 2 goes into 6, 1 goes into 6. But if I didn't see that, I could just multiply all 3 denominators and get a common denominator. So I will pretend that I didn't see that 6 would work, and I will go ahead and use 12. If I use 6, I will get the exact same answer as I would if I got 12. I will get the exact same answer as I would if I used 12. So we have on the left 12 by 3 and 12 by 5. And we have on the right 12 by 7. I remembered my line this time. So 12 by 3 is 36. 12 by 5 is 60 over 6. And 12 by 7 is 84 over 2. Now all I need to do is simplify these fractions. I will have 36 plus 10x equals 42. And now I have all whole numbers, and I should be able to do this thing pretty easily. And I think this one is going to come out to be a fraction, which is kind of weird, but maybe it's one that we just need to fix. So we have negative 36, or subtracting 36 from both sides. And we've got 10x equals 6. And then I do need to divide by 10 on both sides. And I will get x equals 6 over 10. Or, if I were to simplify that, 3 over 5. Alrighty, and Schlegel has time to model one more. On to number 6 here. we have only a denominator of 3, but we also have these which are over 1. So we are going to go ahead and take a look at this and see what our common denominator is. It looks like our common denominator is going to be 3. And again, I could use any common denominator. I could use 3, 6, 9, 12, 15, 30, 60. Anything that both 3 and 1 go into would work. I'm going to go ahead and use 3. And if there's someone out there that wants to try something else, you can do that and you should get the same result that I do. So I will have 3 over 3x plus 18 over 1 equals 10, no, not 10 Schlegel, 30 over 1. And so we get 3 over 3 is 1x plus 18 equals 30 over 1 is 30. And so just like we do, we would subtract 18 from both sides. And we would get 1x equals 12, which is the same as x equals 12. And so with that, Schlegel is going to go ahead and end this video. I will produce an answer key for the rest of this. And I hope that this is helpful, and I hope that you have an awesome day.